Hey everybody, hope you're having a good Friday. I wanted to go over bridge with you so that you had some information leading in to a little bit of review before the quiz so that you're feeling good and feeling ready. So hopefully you had a chance to look over bridge. I just wanted to go through a couple of things that I think are a little bit tricky on it. So the first question asks you to explain in terms of subatomic particles why this excited atom is electrically neutral. So the keywords I see there are subatomic particles. You better mention either that phrase or examples of subatomic particles in your answer. And you also need to tell me why it's neutral. Neutral meaning no overall charge. So when I think about the charge of the atom, my mind immediately goes to protons and electrons, because those are the two subatomic particles that have a positive and negative charge. So if our atom is electrically neutral, even if it's excited, that must mean that my number of protons is equal to my number of electrons. And that's going to be true for an atom, whether you're excited or whether you're in your ground state, because exciting an electron does not change the number of protons or the number of electrons. All right, so when you're moving electrons around, that doesn't change the number of them, just the location. So I want to now to write the electron configuration of the atom in its ground state. So it gave me the excited state of 272. If I add up all those electrons, what I see is that there are 2 plus 7, 9, plus another 2, 11 total electrons. If there's the same number of protons as there are electrons, that must mean I have 11 protons, which means atomic number 11, which means I've got myself the element sodium, Na. And its ground state electron configuration is written right there for you, 281. So I'm going to copy that straight down as my ground state configuration. The last question is what we've been working on for the past while now, thinking about how we can take atoms and make them produce light. All right, we know we need to excite the electrons and get them up to a higher energy level by putting in energy, either in the form of electricity or of heat. We've seen that in the flame tests you've done, or in the more specific bright line spectra, that is the atomic fingerprint for each element and what specific colors it emits, even the ones that seem invisible to our naked eye. I know that alone, just stepping up, doesn't produce light, so I don't want absorbing energy. I know taking energy in isn't what releases light. Light's just a form of energy, so it must be given off as I release energy, moving from high to low. Thinking about jumping off a table, jumping off a stool, I'm releasing my energy when I make that move from a higher excited state to a lower energy state. So I'm going to go with choice number 3. All right, so pause the video if you have any questions that you think your classmates or the sub can answer, ask them now. Otherwise, here's your task. For the next 5 minutes, maybe 7 minutes, depending on how things are going, I want you to take a look at the workshop, which is just a review of some essential concepts. Protons, neutrons, electrons, some notation stuff on the back. We've got stuff with Bohr diagrams and electron excitation. Just review these key concepts, check in with what you know well or what you think you're the most fuzzy on. There's an answer key up front, please check your work, but do this briefly so that you can have as much time to answer all the questions on the quiz, all right? Same protocol as our last quiz. You're gonna answer all questions. There'll be an opportunity to correct any mistakes you make next week. No phones, nonsense business. Don't be dirty cheaters, folks. You know not to do that. Turn in both your answer sheet and the quiz to the substitute. Be good, do well, good luck. I will see you again on Monday. I hope you guys have an excellent Friday and an excellent weekend.